We're going to look at graphing sine and cosine functions today, and then also finding the equations of some sine and cosine functions. But just to remember how graphs are affected by different numbers, remember if you're adding or subtracting in the parentheses with x, it does stuff in the horizontal direction because x goes horizontal, and it kind of does the opposite of what you want. So this one would be 2 to the right, this one's 2 to the left. So once again, here you're inside the parenthesis. You're multiplying so there's going to be stretches. So this one would be a horizontal stretch of a half. Here we'd be a horizontal stretch of 2. The upper 2 on the right and the lower 2 on the left are doing things outside the x after the squaring is done. So then they affect it up and down because that affects the y. So this would be 2 up, this would be 2 down, this would be a vertical stretch of 2, this would be a vertical stretch of 1/2. So if it's outside of your function, it kind of does what you would expect in the y direction or vertical direction. If it's inside your function before your function's applied, it affects x in the horizontal and kind of does the opposite of what you would initially think. So here, this means we would have a vertical stretch of 2. We would call that 2 an amplitude of 2 because your sine function would then go 2 above the x-axis and 2 below your x-axis. This one here is a 1/4, so it would have a vertical stretch of 1/4 and it would have an amplitude of 1/4. Amplitude is always positive. The number in front can be negative, and that would just reflect your graph over the x-axis, flip it upside down. Here we're inside the parentheses, so that's going to be a horizontal stretch, and it's going to make it a horizontal stretch of 4. Your period was 2 pi, it's 4 times more, so it's going to be 8 pi. Here, your horizontal stretch of 1/3, and so then you're going to have a period of 1/3 of 2 pi, or 2 pi over 3. Here, this is afterwards, so it's going to move it up 3. This is after your sine function, so down 1. But here we're inside, so it's going to affect it left and right. So this would be left 2, this would be right 4. When you are shifting left and right, that's referred to as a phase shift when you're dealing with trig functions. So when you're in this form here, or in this form here, the only difference is sine versus cosine. A is your amplitude, and remember amplitude's always positive. If you're looking at your graph trying to work backwards, it's the max minus the min divided by 2. It's how far above and below the horizontal axis it cuts your graph in half. Not necessarily always the x-axis, because if you're moved up and down, it would be the horizontal axis that cuts your graph in half. D, what's being added, is your vertical translation, which is the y equals d is the horizontal line that cuts your graph in half. So half is above, half is below. And if you're looking at a graph trying to work backwards to find the equation, it's max minus min divided by 2. B, what's in front of your x, when x is being multiplied by something, that affects the horizontal stretch, which then affects your period. We use this peanut butter equation. Your period times p, or peanut butter, is equal to the normal period. Normally that's 2 pi unless you're dealing with tangent, which is 1 pi. And then c, what you're adding or subtracting to x, shifts it horizontally, which is referred to as your phase shift. So let's go ahead and find what goes on with this. So this 2 in front of your x affects your period. So we're going to go our period times our b value is equal to our normal period. Our normal period for sine is 2 pi. Our b value is that 2. So then we can solve it for our period, which is what p is, and we divide by 2 and we get our period of pi. When it's in this form, what's added or subtracted to x is your phase shift. So this is going to be pi over 2 to the left. Now, if we did not have this extra set of parentheses here, To find your phase shift, we'd actually have to factor that 2 out. So let's go ahead and identify our amplitude, our period, our phase shift, any vertical shift, and then we'll go ahead and graph it on this one. So amplitude is always absolute value what's in front, so our amplitude is 3. Now your phase shift would be pi over 4 to the right. Our B value is 2, and our normal period is 2 pi, so we can go our peanut butter equation is equal to 2 pi. We can go our period times 2 is equal to 2 pi, and we get our period to be pi. Then we're going to go ahead and look at what D is. D is the vertical shift. That's what's added afterwards, so it's going to be up 2, so a vertical shift of 2 up. So now we're going to go ahead and graph this. What you want to do is you want to start out, what I normally do is start with a piece of paper and tear off the corner of my page and make 2 marks on it that are a set distance apart like this. And then I come along and I take that set distance and put 4 equally spaced marks on my x-axis. You also want to put 2 marks on your y-axis that are equally spaced up and down. How far up and down you go does not have to be how far left and right you go for your tick marks. The up and down distances can be different. So now, for graphing this, we're going to go ahead and graph our sine. Sine starts at the origin. Your 4th tick mark always has to be at the same height. Sine, halfway in between those 2, crosses again. In between the first 2, at this first tick mark, that's where we have the maximum. So I'm going to mark a maximum at my height of my tick mark. In between these 2, the 3rd tick mark, that's where I have a minimum. So I need to mark that. So all these horizontal spaces need to be equally spaced. How far up I go here has to match how far down I go here. So now I'm going to go ahead and do a smooth sketch of my graph. Once I have that in there, now I'm going to come along and put in numbers for my tick marks. This is 1 full period. We know our 1 full period, according to this, is pi. So therefore, this would then be pi over 2. How far up it goes is my amplitude. How far down it goes is the opposite of my amplitude. So drawing in my graph to begin with, and then putting the tick marks on accomplishes, in this case, 2 of the 4 things we have to do. We now have to come along and do our phase shift. Our phase shift is 1/4 of a pi. So here, if this is 1/2 a pi, this would be 1/4 of a pi. So I need to go ahead and move this orange graph, all my key points, and once again, my key points are where I cross my axes, my maximum, and my minimum. I got to move all these points 4 units to the right. So now I'm going to come along with my piece of paper. Now in this case, my piece of paper already matched my tick marks. If it didn't, I'd go ahead and draw in a new tick mark to match how far over 1/4 of a pi is. So now I'm going to come along and I'm going to move everything 1/4 of a unit over. So this one gets moved over to here. Then I'm going to go ahead and move this up. And do another tick mark. Move this one over, and so on. Now I'm going to draw in another smooth graph going between these points. So now all I have to do is my vertical shift of up 2. So at this point, I need to go ahead and figure out what 2 is. Well, here's 3. I need to divide this into thirds. So I need to move everything this far up. So all I'm going to do now is take my piece of paper, turn it sideways, mark that distance, and then move all those key points 2 units up. Now I'm going to go ahead and draw in a smooth graph going between all those points that were moved 2 units up. Now it really continues on in both directions past this, repeating, but all we're doing is drawing in at least one full period. And then I'm going to draw an arrow to this and indicate that this is my final graph. So that's what I would do for graphing them. Now, if you wanted a nicer looking graph, here's a nicer looking graph. Same idea, 3 separate graphs that did the exact same thing that we were just doing on the previous page. So let's go ahead and try to do this one. Our A is -4, so our amplitude is the absolute value of that, so it's +4. The negative flips our graph upside down. Our B value is 2, so our period is using peanut butter would be just pi. Now we have no vertical shift here, but we do have phase shift. But notice this problem did not have that extra set of parentheses. So you actually have to factor a 2 out of the parentheses here and get this. So our phase shift is pi/6 to the left. So now we're going to go ahead and graph cosine. We have to do those 4 evenly spaced tick marks along the horizontal. We have to do 2 tick marks up, or 1 up and 1 down, evenly spaced above and below. And once again, the vertical distances that you're going here do not necessarily have to match your horizontal distances. So now we'll go ahead and do our sine. Sine normally starts out at the top. So not sine, but cosine. No, cosine would normally start here and end here and have a minimum here and cross in these 2 spots. But because we have that negative in front, all this is flipped upside down. Oops. Just a second here. So we're going to start out at the bottom, then end at the bottom, because where you end and start always has to be the same. Halfway in the middle will be at the top, and then we'll cross at these 2 spots. Then we'll draw in a nice smooth curve going in between those. Then we'll go ahead and we'll mark in our full period. This is our full period, which we know is pi. So therefore, this is pi/2. This is going to be our amplitude of 4. This is the opposite of our amplitude of -4. Because we put our tick marks in afterwards, we now have 2 of the 3 things already done. All we have to do at this point is our phase shift. Now, our phase shift is left 1/6 of a pi. First of all, you got to figure out where is 1/6 of a pi. Well, 1/6 of a pi is really having to take our 1/3 of a pi and dividing it into 3 equal parts. So this would be 1/6, 2/6, and then this would be 3/6. So this is going to be pi/6. So we need to move everything this distance here. So I would come along with my piece of paper again and move all my key points that far left. So move it, my piece of paper, and in this case I'm just using my ink. Doesn't make a difference, but you should do evenly spaced ones with your piece of paper, and then you'll move it here and continue on. Then I would draw in a nice smooth graph going between those points. and then indicate that that's my final graph.